Everyone, welcome and thank you for coming to this Learn and Share. I thought I would talk about water quality and extreme events because I have a background in water quality, but for the last few years, I've been essentially looking at effects of climate change and climate resilience of drinking water supply. So I thought this was an interesting chance to sort of combine those two interests. But a little bit about me before I start. I'm from India originally, live in the UK now, and I'm a senior research associate at the University of Bristol. And my background is in environmental engineering. So, extreme events. When I mean extreme events, largely from the point of view of water quality and climate change, we're talking about drought, heavy rainfall that can lead to flooding, landslides, wildfires, and coastal flooding. So we know that these types of events affect drinking water quality, both at the source as well as the point at which people collect that water, whether it is at our tap or a public collection point, which is very common, especially in rural parts of South Asia, Latin America, and Africa. These can lead to service disruptions if the service provider decides to shut off water supply, or in case the service provider doesn't disrupt the service, it can lead to big public health risks. There is strong global evidence for links between especially heavy rainfall and microbiological water quality. Between temperature and cyanobacteria, which is a type of algal bloom, and then sea level rise or coastal inundation of infrastructure and salinity. So I thought, in the interest of time, that I'll focus on some of these events for which there is strong global evidence. The reason I say global is because in places like the UK, there is a lot of data. And I'm sure that there is evidence for a lot more types of links. But for a lot of the places where I work, which is primarily in South Asia and Sub-Saharan Africa, a lot of this data doesn't exist. But I will try and share what evidence there is from a lot of different types of places and for a lot of different types of water supplies. Of course, we are interested in water quality because it has public health impacts, some of which is known quite well. But for some of these links, the public health impacts are relatively unknown from some parts of the world, which I will highlight as I go through. So I'll start with microbiological water quality. Rainfall changes the transport of microorganisms in the environment. So these could be bacteria or viruses or parasites. When there is heavy rainfall or flooding, these microorganisms can get transported to our drinking water supply in one way or the other. There are a few key ways in which this happens, and it depends on the type of water supply that we have. So in a place like the UK, if we have, let's say, a surface water source, the sediment load in that surface water source can increase after heavy rainfall. And this reduces the efficiency of disinfection in water treatment plants, which means that there are pathogens that can go through the disinfection process and end up in our tap water. Contaminants can also directly enter pipes. So if there is widespread fecal pollution in the shallow groundwater, and there is heavy rainfall, or there is ingress of water into damaged pipes, the contaminants can also enter those pipes. In places where the water is being collected directly through a borehole with hand pumps, and the infrastructure is not well maintained, like the apron, for example, is damaged, rainwater can wash a lot of contaminants from the ground directly into the borehole. And then, so these are sort of more localized groundwater contaminant events, but then it is also possible in areas where, again, there is poor sanitation, that a lot of contaminants can go from a leaking septic tank or a pit latrine into the aquifer, and eventually they can make their way through a borehole or a well into our drinking water. These types of contamination pathways exist, but when there is very heavy rainfall or when there's a flooding event, this contamination can become accelerated. Now, the increase in contamination. So for a lot of groundwater or even surface water supplies, with water quality monitoring, there have been reports that indicator bacteria can increase very quickly after heavy rainfall, as quickly as within 24 hours. And this is not just specific to wells or boreholes. Even piped water supplies are susceptible to contamination, especially if the water supply is intermittent. Because when there is very low or no pressure in water pipes, they become quite susceptible to ingress of contaminants. And this contamination can last up to 4 or 5 days after the initial heavy rainfall. Now, there's mixed evidence of the impacts of temperature. There are studies that show that pathogens that cause gastrointestinal diseases may decrease or increase if there is global warming or if there is an increase in average temperature. And so basically what that means is viruses tend to do better in cold weather. And so rotavirus, which is there's a huge prevalence of rotavirus diarrhea, even in the UK, the prevalence of that might decrease if global temperatures increase. Whereas for bacterial diarrhea, such as those caused by pathogenic E. coli or parasites like Cryptosporidium, tend to do better with slightly warmer temperatures up to a certain range. Now, the issue here is that, again, from low and middle income countries, there is not a lot of water quality data to show us that this diarrhea is indeed caused from consuming contaminated water. So these studies that I'm referencing looked at temperature and diarrhea incidence and not temperature and water quality. Now, everybody knows, and we've known for about 200 years, that there are clear links with gastrointestinal diseases and mortality. But as we'll see in the next few slides, that this link is not always very clear for other types of water quality parameters. Next, I'm going to go on to chemical water quality. A few parameters only. Of course, there's a huge range of parameters that I could go on talking about, but I've brought a few that I really wanted to share. One is cyanobacteria, which is becoming an issue in a lot of places as average temperatures increase. So this has historically been a huge problem in areas just north and just south of the equator. Places like China, Brazil have a huge amount of data on algal blooms in general and cyanobacteria in particular, but this is increasingly becoming an issue even for places like the UK. So cyanobacteria, which it's a bacteria, but is often sort of, pulled along with algal blooms, really likes warmer temperatures and is commonly found in stationary surface water bodies like lakes or reservoirs where there is very little to no flow. So there is evidence that warmer temperatures encourage cyanobacterial bloom. There are some reports that windstorms can also encourage cyanobacterial blooms, which basically is because a lot of the nutrients and the sediment that settle down in a lake can get regurgitated. They get mixed in a windstorm because it causes a lot of turbulence. And after the storm passes, as things settle down, the cyanobacteria has all this nice nitrogen and phosphorus to eat and grow really big. Again, why are we interested in cyanobacteria? Because some strains of cyanobacteria are toxic to humans, but the relationship between the concentration of toxins and temperature is unclear. There are some strains that can be quite a bit more aggressive, a bit more competitive than others. but it depends on whether they are toxic or not. And that depends on a range of other factors as well. Now, WHO has limits for the concentration of toxins that are permissible in drinking water for, I think, 4 or 5 different types of toxins. But the health impacts for human beings are not well established in the community. So there are some studies that show that patients on that are getting treatment for kidney failure, they can be they're quite vulnerable to even death if there is toxins in their drinking water. But those are not community level studies. Those are just in healthcare settings. Next, salinity. So coastal flooding, whether that's from sea level rise or whether that's from a cyclone, has been linked to increased salinity of groundwater supply. This is particular risk for areas that are low-lying and also small islands where their fresh water supply is quite fragile. And from a health point of view, high salt content is linked to hypertension, and this is particularly risky for pregnant women who may be consuming groundwater directly. And finally, I'd like to talk about wildfires. Now, this is an interesting one. At least to my knowledge, there is almost no literature on wildfires from places like South Asia or Africa, where wildfires do occur. Generally, when we think of wildfires, we think of Australia or parts of North America like California, where these occur on an annual basis almost. So in terms of the water treatment supply, if the catchment is forested and if you have a wildfire, it can increase the organic carbon that is entering your water treatment plant, and it can affect water treatment efficiency. What that can do is that it can increase the organic carbon as well as the disinfection byproducts in treated water. But again, the health impacts of this are not very well explored. So I'll wrap up by just going over some knowledge gaps. Again, I think because of the type of work that I do, this gap primarily exists in low and middle income countries. But I'm going to try and make it a bit more general. So the impact of decreased rainfall on geogenic contaminants is unknown. And by geogenic contaminants, I mean those contaminants that naturally occur in groundwater. The two big ones are arsenic and fluoride. So if there is excess fluoride, that's not good for public health because it can cause fluorosis. Chronic exposure to arsenic is a carcinogen, and it causes arsenicosis as well. Now, there is absolutely no literature on whether a decrease in rainfall might mean that these contaminants are not diluted in groundwater anymore. Will their concentration go up, or will it somehow mean that these contaminants stay in the solid phase and don't dissolve in water? We don't know. Then for piped water supplies, what does the increase in temperature mean for the efficiency of water treatment processes, biofilm growth in piped water supplies, and other opportunistic pathogens? We don't have much evidence for that. And finally, like I said before, the evidence that we have so far on cyanobacterial blooms and wildfires and their impact on drinking water supply is from a very limited number of countries, and their health impacts are unknown. So that's where I will wrap up.